Hi, good afternoon, everybody. If you are hearing and seeing, just let me know, and we're going to jump right into today's session. Okay, so we're going to jump right into it. Just give me one more minute. I have a small headache, so just give me a minute. Bear with me. All right, so today's session. Okay, so today's session is going to be algebra. Did everybody get a chance to look at the post that I sent you regarding the topics that come in? No, for maths is not as for maths, unfortunately, is not as specific, but what I found this year compared to other years, they actually gave us some hints. So I want you guys to pull out your phone and just take a look at it because I'm just going to outline some stuff. And I think you should pay attention to these things when you are revising. So the first thing I'm going to go through is point number one. Number theory, consumer arithmetic and computation. That's everything. They don't ever tell you whether it's higher purchase, simple interest, which means you need to know everything. And lucky for us, we have gone through everything under question number one. So you should be good to go. Today, we are going to be looking at algebra. So what we see here is that they're talking about indices. And you should know what indices mean. Indices means powers. So all of the laws of indices, what do you do with algebra terms when you're adding, subtracting, multiplying, and dividing? Then you have linear and quadratic equation. And you should know what a linear equation is any equation where the power on any variable is just one. So for example, x plus 2, 2x plus 5, 2y plus p. There's no square, there's no powers on those terms. And then you should know paper one is the multiple choice. That's what we've been practicing. Paper two is the written questions. Okay. Quadratic, you should know what quadratic means. Quadratic means that the highest power is 2. So x squared plus 3x plus 2. That's a quadratic expression. Then, they talk about formulas, and, there's different types of formulas. There are formulas that you have to change the subject of the formula. There are formulas when it comes to factorization. There is formulas when it comes to a lot of different other things that we should know. The quadratic formula, we should remember the quadratic formula to solve. And then they have direct and inverse variation. So all of these things we're going to look at today. So we're going to start from scratch and we're going to revise everything on the algebra. Tomorrow, I'm hoping to have class, but I can't promise because I have to go to Washi for a face-to-face session with some younger students. But once I come home and I can, we should have class tomorrow. And I would like to focus on functions, relations, and graphs. All right, so if you guys are ready, just say ready and we're going to begin. So that's one, that's two. Remember, all I need you guys to do is respond accordingly. So because algebra is so in-depth, I cannot write out all of the things we're going to be doing. So you're just going to follow as I move through, okay? So we're going to start off with, let me just zoom out completely and go in the corner. So let's start in this upper corner here. All right, so the first thing we're gonna do is the integer laws. And you should know what integers are, right? What are integers? Integers are positive, negative numbers, and zero. All three of them make integers: positive numbers, negative numbers, and zero. And we should know zero is always between what? The positives and the negatives, right? So we're going to look at addition and subtraction rules. Then we're going to look at multiplication and division rules, which are the same actually. So let's go. When it comes to addition and subtraction, when the signs are alike, we should remember the rules, right? What happens when the signs are alike? Let me use a different number. When the signs are alike, we add the numbers and put back the sign. So we know we don't have to put a positive because we know 5 by itself is the same thing. But when it comes to -3 minus 2, we add the numbers and we put back the sign. Everybody with me? But what happens when the signs are different? So what happens when the signs are different? Different means difference. What does difference mean? Difference means to subtract. So you subtract the two numbers, 3 minus 2 is 1, but your answer takes the sign of the bigger number. Here, the bigger number is 3 and it's positive. So here the answer is +1. Unfortunately, the next example, what do you realize? The signs are different. So you subtract, you get 1. But who is the bigger number? -3. So the answer is -1. If everybody got it, let me know, because these are things we need to remember. This applies for algebra, letters, numbers, all the rules apply. So that's one person. Let's go, guys. Let's go. Drop your feedback. So just a quick reminder with addition and subtraction. When the signs are alike, you add the numbers, you put back the sign. When the signs are different, you subtract the two numbers and you put the sign of the bigger number. Now, when it comes to multiplying and dividing, the rules are the same. So for example, when the signs are alike, again, a positive times a positive is a positive. So when you multiply two positive numbers, the answer is positive. When you multiply two negative numbers, the answer is positive. So a negative and a negative is a positive. A positive and a positive is a positive. But when the signs are different, doesn't matter which one comes first. Once one of them is negative, the answer is negative. Everybody with me? Let's go. If you got it, say got it. Now, one of the other things we need to remember is sometimes we have something called clashing signs. What does clashing signs mean? Clashing signs mean if for any reason an addition and a subtraction sign come together, it turns into what? A subtraction. Similarly, if a negative and a subtraction come together, or both negatives come together, it turns into what? A positive. So let's get some examples. We have 3 plus -2, 3 minus -2. What do you end up here with? What's going to happen? This plus and this minus going to turn into what? Subtract. So we're going to end up with 3 minus 2. 3 minus 2 is what? 1, +1. Everybody with me? And here we have two negatives. A negative and a negative come together gives us a positive. So we're going to have 3 plus 2 is equal to 5. So these are the basics. This is the backbone for everything that we're going to do in algebra, because you know we always deal with negative and positive signs. So I'm going to give 3 questions and I need everybody to answer them as soon as possible, just to make sure we're on the same page. So all I need is the answer quickly. So the first one, answer. And these are things we should be able to do quickly. Let's go. Let's go. I need to see some answers rolling in. Excellent job. Next one. Let's go, let's go, let's go. Don't forget, it is the signs are different. So you subtract the two numbers, you can get 5. But who is the bigger number? Negative 15 is bigger. So it's going to take the sign of negative 15. That's how we got negative 5. What about this one? 3 plus negative 10. What's the answer for this one? Excellent. Because we know what's going to happen here. This is going to become negative. So we're going to end up with 3 minus 10, which is negative 7. Last one, negative 4 minus negative 10. A lot of different answers. You see how everybody gets thrown off? You see how everybody gets thrown off? Try again, please. Try it again, please. Because the first thing you have to deal with is the clashing signs. So this is going to become negative 4 plus 10. You see how we got to be careful? Don't ever take anything for granted, okay, guys? So the answer is positive 6. Because the signs are different, so you subtract, you get 6. Who is the bigger number? Positive 10. So the answer is positive 6. Okay, this is the difference between a grade 1 and a grade 2. All right, everybody good to go? We're moving right along. So we're going now into algebra rules. And we should know, when I talk about the algebra rules, what are we talking about? The 4 different types of operations. Addition, subtraction, which apply the same rules. Then we have the multiplication and division rules. And you should know what rules should come to mind when you're dealing with multiplying and dividing any algebra terms. The laws of indices. Agree or disagree? So let me go. What is the rules for addition and subtraction? What is the general rules for addition and subtraction? You can only add and subtract what? Like terms. So if I tell you add A plus B, what's the answer? Because there is an answer. The answer for A plus B is simply A plus B, because I could do nothing. I cannot add them. So I put them back. So don't ever leave a blank. You write it back. So if I had A plus 3B plus A, what would my answer be? I would first have to rearrange all my like terms together. Keeping in mind, each term takes the sign in front of it. So I have some A's, so let me put all the A's together. So that would be A plus A and then plus 3B. So you write that. A plus 3B. What can I add? I could add the A's. An A plus an A is what? 2A. What is the coefficient of A? 1. Everybody see that? So I want to take an opportunity to remind you about certain things. If I have 3A squared, what is the variable? What do we call the variable? Who is the variable? Excellent. A is the variable. Who is the coefficient? 3. Who is the index? Because we remember index means exponent. And another word for exponent is what? Power. Another word for power is order. Don't forget, I teach you this already. So don't forget these things, okay? Now, is there a constant in this term? Do I have a constant here? No, because a constant in algebra is a number that stands by itself with absolutely nothing before or after it. Everybody with me? So we're moving along. We need to remember, so if I have P, I know P does have a power. It does have a coefficient. The coefficient is 1. The power is 1. So that's something we just forget when we multiplying and adding. So don't ever forget. It's just understood. You don't say P to the first power. You see, we know that it means P by itself has a power of 1 and a power a coefficient of 1. Similarly, what does 2P mean? We know that 2P means what? 2 times P. Agree or disagree? Similarly, if we have AB, what does AB mean? When we put two variables next to each other, we know it means A times B. So these are all the things we got to make sure we remember. So let me give a complex question quickly. If I had 4A squared plus 3A plus 2A squared, what's my answer? I know that I have like terms. The A squares are like terms. So I rewrite it 4A squared plus 2A squared plus 3A. So the only two I can add is this. Right or wrong? So your answer is simply 6A squared plus 3A. Why is that? When we add, do we change the powers? Remember, think about it. Adding is just like you're putting things together. So is it almost like I put all my apples together, all my bananas together? Does me adding apples change what I am adding? So if you add an A square, it could never become A to the third power, A to the fourth power. Everybody with me? Remember, that's addition, like terms. Everybody with me? Let me know, please. So everybody see why this is the answer? So this is quick reminders of things you should not make mistakes with. Pay attention to the rules. Addition is just grouping. You look for the like terms, you add them together. So I'm going to take it up a next notch. And you only add the powers when you're multiplying. And that's what I'm saying. That's the basic rules that you're not remembering. Okay? So make sure you get that in your mind clear right now. When you're adding, the powers don't change. You're adding the like terms. When you multiply, that's where the laws of indices come. That's when the powers change. So let's do another one. If I had 3A squared plus 2A minus 6A squared. Let's go. What we're going to do here, we're going to group the like terms, right? So you end up with 3A squared minus 6A squared plus 2A. How much things can I add? Can I add all three or only two? Excellent, only two, because only 3A squared and 6A squared got the same variable. And remember, that's what we call like terms. It must have the same variable. Even though this is an A and this is an A, it's two different types of A. Why? We know A squared means what? A times A. Agree or disagree? That is not the same thing as just an A by itself. So keep that in mind, okay? So let me go. This is almost like saying this. 3 minus 6. You know that? What is 3 minus 6? Everybody, what is 3 minus 6? And you see how we just did these here before? Is it positive 3 or negative 3? Which one? Remember, we got to lock these things in. It is going to be negative 3. So if you have 3A squared minus 6A squared, it must be what? Negative 3A squared. And then you put back the plus 2A, because can we add anything to 2A? No, we cannot. So everybody with me? These are questions you should never make a mistake. These are the things we need to know the difference. Now we're going to move on to the multiplying and dividing. Now this is where we're going to use the laws of indices. So let's take a look at what those laws say. And this is what you would remember when it comes to like adding the powers. So I'm going to go through all of the laws. The first law talks about A to the M times A to the N. What do you do when you're multiplying two letters or two variables with the same base? What do you do with the powers? You add them. So it's going to be AM plus N. So what is an example? P to the third power times P to the second power. What is my answer? P to the fifth. Remember, it's not going to be 6 because you do not multiply the powers. You add them. And with that, I'm going to add an element. 2p to the third power times 3p to the second power. Now, what is my answer for this? What do we remember? When it comes to the coefficient, is a different rule. You actually have to multiply the coefficient. So it's going to be what? 2 times 3 is 6. And then you treat the variables separate. So p to the third power times p to the second power is what? P to the fifth power. Everybody got it? Let me know because this is our revision. This is our revision. So one example before we continue. Suppose I give you 2m square p to the third power times 5mp. Everybody need an answer, please. What is your answer? Are watching, eh? Are watching. So there we go. What's the rules again? What's the rules again? You multiply the coefficients. So that's going to be 10. You know, you got two different variables. You got m's and you got p's. So this m has how many powers? 1. This one got 1 as well. So, you know, you're going to add it. So you're going to have how much m's in all? 3 m's and 4 p's. If you got it, say got it, because we're going to move right along into this second law. So just like how everything in math is balanced, if when we multiply two variables, we add the powers, obviously what can happen when you divide? So a to the m power divided by a to the n power, you simply subtract. No, I'm gonna be honest with you, based on observation, students just forget this. And so it is important for you to just lock this in your brain. So let me try one. Q to the 6th power divided by Q to the 2nd power. Is the answer Q to the 3rd power? Exactly. The answer is, and please remember, because you want to maximize your score, even though this is easy, you show them you know the rule. So you're going to put what? 6 minus 2 first, and then you're going to come down and you're going to put Q 4. Everybody with me? So right now we're looking at getting to the next level. Show everything. Show everything. All right, so let's try one. Sometimes it comes like this, right? Look at this. 20m to the 5th power, p to the 6th power over 4mp. Everybody realize what this means, right? Just like in fractions, what does this line mean? This line means to divide. So I could rewrite this to look like this. 20m to the 5th, p to the 6th divided by 4mp. Agree or disagree? Remember, we learned short division as well. Short division is like this. 4 into itself goes once. 4 into 20 goes 5 times. This is a power of 1. This is a power of 1. So if I scratch out this and I scratch out 1 from up here, I'm going to left back with 4. Right or wrong? If I scratch out 1p from here and I scratch out 1p from up here, how much can I left back in? 5. So you're going to end up with what? 5m4 p5. Let's do it the long way. 20 divided by 4 is 5. M to the 5th power minus 1. P to the 6 minus 1. So we're going to get 5m4 p5. If you got it, say got it. I'm watching. Somebody say kinda. If somebody say kinda, let me know, please. All right. Next law. Anything raised to the power of 0 is what? One. We can't forget these things. Let's show an example. P to the third power divided by P to the third power. So let's do it the long way. What does this mean? P3 minus 3, right? Is equal to what? P0. But let's work it out. We know that this also means this. P to the third power over P to the third power. Everybody with me so far? And what does P to the third power mean? P times P times P over P times P times P. So let me know if everybody see how I got from here to here. And I just want to take this opportunity to explain. If they ask you to prove something, you don't have to make it up, you know. You just got to break down what these things mean. So everybody see how I was able to show my evidence, my proof. I just breaking it down so you see how you get the answer. So let me go. We know what we're supposed to do when anything set up like this. Cancel, right? Cancel to the top and to the bottom. So if I cancel this, P can go into itself once, P can go into itself once. P can go into itself once, P can go into itself once. P can go into itself once, P can go into itself once. 1 times 1 times 1 is equal to 1 to the top. 1 times 1 times 1 is 1 to the bottom. Anything over 1 is itself. So everybody see how something P to the 0 is equal to 1? Hello? So it doesn't matter. It could be 3. 3 to the 0 is 1. And remember when we were doing the bases in last class, 6 to the power of 0 is 1. M to the power of 0 is 1. Can y'all hear me? Can you hear me now? Okay, good. The Wi-Fi just glitched a little bit. All right, so how everybody feeling? So that was the third law of indices. The next one is anything is AM brackets N. What does brackets mean? Exactly, brackets got two meanings. Oh, why am I foot cramping? Hold on there, guys, are cramping up. Sorry, I was working all day, so my body kind of shutting down, but that's okay. We got this. So yes, as I was saying. So here we should know that you multiply the powers. This is about the powers now. Because if you realize you have a power on the outside of the brackets and a power inside the bracket. So this just means AM times N. Everybody see that? So an example would be A to the third power brackets 2. This is the only time, because let's be real. What does this mean? This ain't mean everything in the bracket times itself twice. So this essentially means A to the third power times A to the third power. Talk to me. And we know the rules. When you're multiplying two variables, what do you do with the power? You add them. So that's 3 plus 3, which is what? A6. Everybody see that? And then we know A 3 times 2 is equal to what? A6. So if somebody was to say, prove that this law is correct, look at how you prove it. You know that anything square is by itself twice. And you work it out and you show that the answer is the same thing. That's how you prove something, guys. You always show the left-hand side whenever you gotta prove something. Whatever the left-hand side is, you prove that is equal to the right-hand side. You break it down until both of them equal. It doesn't matter what it is, okay? All right, so one last rule that's very important, because to be honest, majority of the rules, the other ones, so they don't really bring them, but we're gonna go through all just in case. So the next rule is the inverse rule. What does that mean? A to the minus 1. What does a to the minus 1 mean? One over a. Excellent. That's it. Okay. And just for the purpose of proving it, let's look at it. Suppose I have a squared divided by a to the third power. Everybody see that? We know what the division means. Division means to us. So what they say, prove this, prove it. Okay, no problem. I know that division means to subtract the powers. So that means I have to say 2 minus 3. Agree or disagree? And we know 2 minus 3, the signs are different. So you subtract 3 from 2, you get 1. Who is the bigger one? Minus 3. So your sign will be negative. But let's do it the long way. A squared divided by a cube means what? A squared over a to the third power. Hope everybody following. A squared means what? A times a. A to the third power means a times a times a. Let me know if you're with me. So what do you do again? You cancel. This and this into itself goes once. This and this into itself goes once. So you realize the difference here? 1 times 1 is 1. But look at the bottom. Everybody didn't cancel. Or who was left back? A was left back. So you see how they prove to be the same thing? You realize the 2 different approaches? You use the rule approach to get the first one. You use the long approach to get the next one, to show both of them are equal. Let me know if y'all good to go. And based on the syllabus, I think that's the only updated one. That's the only one we need to know for now. So you're good to go. That's all they have here in the syllabus. They got 2 more, but I don't think it's necessary because even with the questions, they did not show up. All right, so guess what? We are done with this. So let's quickly do some examples with the actual rules. Let's make sure we understand because we have to make sure we know what to do if a question comes. So let's look at this. 3a squared b to the 4th power times 2a4 b2 divided by 6ab. Now, in maths, whenever you have 2 or more operations, what do we have to apply? No matter what topic, we must do what? BODMAS. Yeah? And BODMAS means you do division and multiplication, but you do the one, when it comes to division and multiplication, who comes first? The one that comes first. So if division was first, you do the division first. It's the same thing with addition and subtraction. If these are the 2 you have to choose between, you do the one that comes first. If subtraction comes first, you do it first. But if it's addition and multiplication, which one you would pick? Let's go, let's go. If it's between addition and multiplication, which one do you pick? Okay. Very good. You have to pick the multiplication. So let me just take a moment to highlight this because this is something students forget. BOD, and some people say BOMDAS. Let me use BOMDAS. Brackets, order. The O does not mean over. And we know what order means. What does order mean? Order means power. So it's the first thing you always do is the brackets. The second thing you do is deal with the power. And then these 2 come together. So you do the one that comes first. And then these 2 come together. You do the one that comes first between them. But multiplication and division will always come before addition and subtraction. Everybody remember that? Feedback. Taking a pause. Feedback. Okay, I'm moving a little fast, so just want to ask a quick question. Everybody okay? Everybody's following in terms of like what we're covering so far? Okay. Okay, good. All right. So let me take a look at the question now. So as we see here, we got multiplication and division, and because it's M and D, you do the one that comes first. So do not try to do all of this one time. Problems. That is where you set yourself up for mistakes. I am not saying it is impossible, but I'm saying, what are we aiming for? We are aiming for full marks. Full marks mean show every single thing. So let's multiply first. 3 times 2, you know the rules for the coefficients is 6. Then you apply the rules for the variables. So you got a's. So what we're going to do with these a's, I'm going to add them. So I know that's a to the 6th. Everybody agree? Same thing with the b's now. B 4 and 2, because we multiply, we're going to add it. So it's going to be b to the 6th. Now, we are done with this part. So now we could bring down the second part. So we put divided by 6ab. Good. There we go. 6 divided by 6 is 1. In math, do we write a coefficient of 1? We do not. You're not going to get it wrong, but it's our understanding. So what should I write then? I skip that. So we have no coefficient unofficially. So for the purpose of explaining, I'll write 1 for now, but we're going to modify it going down to the end. So let's go. Let's deal with the a's now. So the a's, it's 6 and 1, because we know a has a power of 1, b has a power of 1. Don't be afraid to write it in with your pencil. Since we're dividing, what do we do with the powers? We subtract. So it's going to become a what? Wait, I lost my pen. Let me know if y'all are seeing, because it just froze a little bit. All right. So as I was saying, yes. Everybody still seeing and hearing? Okay, good. So our variables would be a to the 5th power, b to the 5th power. But since we don't really record the 1, our final answer is just really a to the 5th, b to the 5th. Yeah, if you got it, say got it. Let's go, guys. Let's go. All right, so we're moving along into substitution, which is our next topic. And we should know what substitution means. What is substitution? And this comes a lot, and this comes in different topics. So this is an important skill. If you are unable to substitute, that's a serious problem. A serious problem. Substitution is whenever they give you an expression with variables, and then they give you the values of those variables. So I'm just going to go with a hard question one time. X plus Y plus Z over X. Sorry, let me try another thing. It's not this what I have written down. I could have given that, but XY plus Z over X, where X is equal to 1, Y is equal to 2, Z is equal to 3. So what does this mean? Everywhere you see X, you put what? 1. Everywhere you see Y, you put 2. Everywhere you see Z, you put 3. But you can't just plug them in. You must look at what the expression is saying. And if you check here, what does XY mean? What does XY mean? It means X times Y. Please, you see how I could distinguish between my X and my times? I hope you guys are making sure you could tell the difference, because you could confuse yourself. You could confuse the person marking your paper. All right. So that's X times Y plus Z divided by Z by X. So now you're plugging your values. So you know this means what? 1 times 2 plus 3 over 1. What do you do first? And I love that expression that Janella took, because you actually can do it this way as well. 1 bracket 2 plus 3 over 1. Because you know, what does brackets mean? Bracket means to multiply. Yep. So Getting back here, we know we got to multiply before we add. So we're going to end up with 2 plus 3 over 1. The answer is 5. Now, guess what? I bet if I chuck in here a negative, people in shambles. If I plug in a negative, people in shambles. And what do I mean by that? They let integers, so if I had -1, y, -2, z, 3. Suppose I ask for this, the same thing, xy plus z over x. Let's go, everybody. Let's substitute it. So what that means -1 times -2 plus 3 over 1. What's the answer for this? I see in cricket, you know, let we go. See, that's why I asked. That's why I asked. Right now, oh, it's -1. Yeah, sorry. That's why I asked. Shambles already. There we go. -1 times -2 is what? +1. +1. I ain't hear me about +1. My mother's here. +2. Sorry about that. 3 over -1. Yeah? Equal. Now, I want you guys to see something here. If you're going to go straight across, go straight across. If you're going to come down, make sure your equal sides are under each other. Okay? Just make sure it's neatly outlined. So we're going to have what? 5 divided by -1. And what is 5 divided by -1? 5 divided by 1 is 5. But a positive divided by a negative is what? A negative. Everybody with me? All right. So let's be honest. Should you be okay with substitution? And when I say okay with substitution, it doesn't matter if they bring an equation that look like this. X plus y over z plus, sorry, I was getting a little excited there. Over z plus x. Would you be able to do this? Do you understand the steps taken to do this? Because this is something, again, people will be in shambles. So for the purpose of knowing what we need to do, let's use all positive values for now, but let's go through a question like this. So what would be the final thing? What would be the last thing that you do in the square root? So you put back the square root. And so what should you deal with first? The substitution, right? So you would put 1 plus 2 over 3 plus 1. Everybody agree with that? Square root over 3 over 3 plus 1. Everybody see that? Equal to what? 3 over 3 is what? That's a great question. What is 3 over 3? What is 3 over 3, people? That's one answer. Jeez, guys, come on. Okay, it means 3 divided by 3, but what's the answer? The answer is 1, because any number over itself is 1. 5 over 5 is a whole. 6 over 6 is a whole. So essentially, what do we end up with? 1 plus 1, which is equal to what? The square root of 2. What is the square root of 2? If somebody say, I want to fight you right now, you can't calculate this without a calculator, because 2 is not a square number. Agree or disagree? The square root of 2 is 2. If you calculate a gear that straight way right now. Everybody put in a square root of 2 in your calculator right now. Tell me where you get. Because we need to make sure we calculate on point. You should get 1.4142, boom, blah, 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 blah. Okay, everybody with me? So everybody think they could handle substitution of any nature? Because if that comes, I expect everybody to be able to handle it. Yeah? Okay, so now we're moving on to binary operations. And what we should remember about binary operations is that the binary operation is a type of operation that combines basic operations together. It's like some instructions. So for example, if I tell you P star Q, and please note that the symbol could be different. The symbol could have been a circle, it could have been a triangle, it could have been a rectangle. It doesn't matter what symbol they use because we know that there's no direct operation that deals with a shape. So whenever you see a shape, you should know, oh yeah, binary, that means it's a combination of a few operations. So suppose I say this means 3Q plus 2P. What do we realize here? P always represents the first number and Q always represents the second number. And look at what the instruction said to do with those numbers. You multiply the second number by 3 and you add it to the 2 times the first number. So this is a trick question for everybody. This is a trick question for everybody. Find, I just want the answer. There we go. You see how much different answers we got so far? I see 17, 16, 13. Ah, boy. So let's go. We got a lot of work to do. So here, which one is the P? The 1 would be the P. Agree or disagree? And the Q would be the 5. So P is equal to 1 and Q is equal to 5. What does the equation tell us to do? The equation said to multiply Q by 3. And what is Q? 5. Plus 2 times P. What is P? 1. So 3 times 5 is 15. 15 plus 2 is 17. You know what y'all got it wrong? You ain't paying attention. You see P, you're just throwing 1 here, you're just throwing 5 here. But you have to be careful because P has a value. Based on the expression, P is 1, Q is 5. So everybody's seeing these things you have to be careful with. And that's why I gave you this exact question, because this is a question that made a lot of students get around because they just assume that P is this and Q is that. No, you take nothing for granted. We leaving no crumbs in the exam. Y'all, let's take too much things for granted. And I'm telling you now, before the exam, please to get rest, be rested. You know why it's important to be rested? Make sure you sleep and make sure you eat. Because if you're tired, if you're hungry, it is going to be harder for you to see these things. Agree or disagree? You want to go into the exam in a good mental space, not stressed, not overwhelmed, not tired. So I tell you now, I know the class before the night before, all I'm gonna do is send you a voice note praying for you. If you want, you can have a little session, but you should not be up past 9 o'clock. So I don't even mind doing a little session, but you cannot be up past 9 o'clock. You gotta go to sleep. You gotta get rest. You gotta go. And before you go to sleep, drink a lot of water so that your body could be hydrated. If you're with me, say you're with me. Because me and talk, I know what I'm saying. I know what I'm saying. When I did CXC, I did my exam twice. I was so hype and so ready and so mentally on. I finished my exam in the first hour. And I get frightened. I was like, how everybody still on question 4. I do the whole exam over again. You gotta be like that. You have to be ready. You have to be ready. Okay, so hopefully this made my point, which is don't take nothing for granted. Pay attention to everything. Read carefully. All right, but everybody understand the essence of binary operation. Suppose my next question says, prove that P star Q is commutative. Anybody remember what P commutative mean? Commutative means that if you find 1 star 5, that should be equal to 5 star 1. Commutative or not. Agree or disagree? Then what commutative mean? So guess what you're going to state? You cannot just state this directly. So let me do it properly so you could see. So this is a proper example of how to prove a law. So if they say, prove that this binary is commutative or not, you're going to give a sentence. You're going to say, if P star Q is commutative, that means that 1 star 5 is equal to 5 star 1. And why did I use this? That the first thing they give me to find. Why go make up 2 new equations when you could use what you done find already? You done find 1. You don't know what 1 star 5 is. Agree or disagree? So all you need to go and find is who? Ain't just 5 star 1. Talk to me. This is where sentences come in CXC. Sentences. You have to use statements. So I can say, if P star Q is commutative, that means that 1 star 5. And then I'm going to say what? Since, and you could even put in brackets, as seen above, because you let them know, you know that you don't do it already. Don't do this all over again, because then they're going to say, well, this person ain't paying attention. Why would they go do this again and they don't do it above? So I would put as seen above. You know that 1 star 5 is already equal to 17. Then 5 star 1, and that's what you got to find. And we know how to find it. We know P is equal to what here? 5. Q is equal to 1. So therefore, what is the formula? Anybody remember? It's 3Q. It's 3Q plus 2P. So you're going to put what? What you're going to put? 3 times 1 plus 2 times 5. Everybody see that? Where did I get this from? Remember, P star Q has a meaning. Look at it here, right to the top. That's the question itself. This is the formula you're going to always use. 3Q plus 2P. Okay, so let's work it out. When we work it out, we end up with 3 plus 10. So that means that 5 star 1 is equal to 13. What do you think my final sentence should say? Since 1 star 5 is equal to 17, and 5 star 1 is equal to 13, they are not what? They are not equal. And if they're not equal, what do you say? Therefore, which is these 3 dots, or you could use the word therefore, or hence, it is what? Not. Put in a capital letters too. Commutative. Remember, they didn't ask if they're equal, you know. You have to say what? They asked what to prove if it's what? Commutative or not. So everybody see that? And this is just a heads up. There's no binary operation based on what I know that is commutative generally. Okay? So this is how you prove something is commutative or not. You work it one way, you work it the other way. If it's equal, it's commutative. If it's not equal, it's not commutative. So that's it. Everybody good with binary? Talk to me, talk to me, talk to me. We're moving a little fast because we've done almost 5 topics so far. Guess what we're going to move into now? We're going to go into distribution, and you should know what distribution means. You should remember, based on the distributive law, is to share something over brackets. In other words, distribution also means what? What's another word for distribution? Expanding brackets. No, this ain't English class. If I spell something wrong, yeah, don't judge me. Distributive is the same thing as expanding. So just to make sure we're on the same page, we're going to do some practice quickly. Some quick demonstrations. So if you're ready, say ready. We're going to do single brackets and double brackets just to make sure we are all prepared. So that's one person. Let me sip on some water. Make sure y'all got a little water next to you. As people doing exams are letting you know, it is extremely important to stay hydrated. Your body, your brain. Your body, your brain needs it. It helps you to keep your body, like, you know, when you put oil in an engine to keep it functioning properly, yeah, it helps you avoid headaches as well. So I just want to encourage you guys to drink water, lots and lots of water. Okay. All right. We are ready to go. All right. So demonstration 1, a very basic expansion question involving all variables. So if you didn't remember, you should see it now. This means you multiply everything outside the brackets by everything inside the brackets. And as we see, we have 2 things in the bracket. So it should be a times x plus a times y. And that's all I'm going to write out. A times x plus a times y. A times x, you see how I put in the equal sign right under? A times x is ax plus a times y, ay. Can I add these 2 together? No, I cannot, because they are not like terms. Even though they share an a, they have an x and a y, which is different, so it makes it different. All right, let me go. Let's keep it moving. Everybody following? Pretty easy stuff, right? Let's use a constant instead. It doesn't change anything. The same rules apply. We multiply by the 2 to the a and the b. So we're going to end up with 2 times a plus 2 times b. So we're going to end up with 2a plus 2b. Let's take it up a next notch. Let's incorporate a negative sign. So we have here -4, and this is where y'all is getting shambles. So I'm just gonna literally take a little minute to highlight what mistakes to avoid. So if you follow the rules, what are you multiplying by? You are multiplying by -4. So check this. This is what you should have written down. -4 times a plus, just like what we was doing before, -4 times b. Everybody see that? So check it out. Equal -4 times a. I put in the plus sign big, plus -4 times b. BODMAS, what do we do first? We got to multiply first. So you're going to end up with -4a plus -4b. Now, when you look at this, you realize, oh my goodness, oh wow, I got clashing signs. So you should know what to do with clashing signs. You got to deal with it. You know what I'm saying? So you're going to end up with -4a. Instead of these 2 signs, it's going to become 1. Which sign these 2 going to become? You realize both of them changing into 1. So don't bother and do this, because this is what others do. You know that's true? It is 1 negative sign is going to become, not 2. So do I do anything else here? I cannot, because I cannot subtract 4b from 4a. So no bother go and do this. I'm making sure I make the mistake so y'all see what not to do. Is this could ever be correct? It cannot, because we have to remember the addition and subtraction rules. I can only subtract like terms. All right. So how we feeling about that quickly? Because now we're going into double brackets. But before we get into double brackets, I want to do the one with the double negative. So just confirm if you're okay. So let's try the same terms, -4. But instead of a plus b, let's look at a minus b. I want everybody to tell me what the answer for this is. So that's 1. Excellent job, everybody. Excellent job. Excellent job. Excellent job. So, let me ask a question. Is my energy too hype? Or it's okay. It's keeping y'all with me. And I don't want to come off too much. Okay, good. If 1%, just right. Okay, good. All right. Okay, let me keep it moving. Good. All right, so let's go, because we got this. So we got -4 times a, right? Minus the -4 times b. So we got -4, the minus. Oh shucks, I forget the a. Sorry about that. That happens sometimes, eh? So always back check quickly before you move on. So -4 times a, that's it, minus the -4 times the b. Same thing, we multiply first. So we're going to end up in -4a minus -4b. Then you see what? Then you see the clashing signs. What are going to turn into? A plus 4b. All right. So we're good to go with this. We're good to go with the single brackets, regardless if it's positives, negatives that we're multiplying by. So now we're going to head into the negative brackets. I'm just going to do a quick demonstration with the negative brackets. And then we're moving on into algebraic fractions, which I know for a fact we, the people, struggle with. It's not our strongest feature as it pertains to algebra. We struggle with algebraic fractions. I know. And then I think after is simultaneous equation and solving, and then factorization, and then that's it. So we're going good. Let me just take a brief run through of the syllabus. I want to make sure I touch upon everything. Okay. Let me ask this question. Y'all okay with changing expressions into equations? So we did a lot of it in paper 1, where they will give you sentences about John has a certain number of apples. This person got 5 more. What is the expression? Da, 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 da. So we should be good with that, right? Okay, I see some people saying no. If you did not attend the classes that we did a lot of those in, please go back and watch the videos. We did a lot of those, especially in if you go in Google Classroom, you would see the tab that gives you all of the revision questions, and each question has its own YouTube link where we did all the past papers. So go through those, please. I've been watching the views, and I could tell who watching, and I could tell how often I'm watching, and I could tell that some people ain't studying it, but that's okay. At least I know that information is there. You gotta know what you want and what you need. Okay. All right. So let's keep it moving. So if I have double brackets, x plus a. Oh no, let me do it a different way. So let's do it another way. So let's say a plus b in the first bracket, then x plus y in the second bracket. There are two ways you could do this. I have taught you several ways. I've taught you the way that avoids most of the mistakes, and I've taught you the double bracket way. So I'm going to do it both ways. So this way really requires you to take the first term multiplied by the whole bracket, and then the second term and multiply it by the whole bracket. Y'all remember that? So it would have been a times x plus y plus b times x plus y. This is the easiest way because, to be honest, it's hard for you to make a mistake here because you know how to multiply a single bracket. That's ax plus ay, right or wrong, plus bx plus by. Everybody agree or disagree? Versus the other way, which is no problem. Again, it's based on what you are most comfortable with. If you're comfortable with the second way, you do the second way. And that is just saying this. This is the second way. A times x plus a times y. B times x times b times y. Now, in general, you usually always have two things you could add here. But in this example, there's nothing that I can add here. Everybody realize that, right? Let me go across. I can't add nothing here, because all of them are different variables. Ax is a different variable to ay. Bx is a different variable from by. All right, so let's do it the long way. A times x, which is ax. So ax plus ay, then you got plus bx plus by. All right, so just for the purpose of practicing, everybody get your pens out, please. I need you to expand this bracket quickly and then type your answer. X plus 3, x plus 2. Quickly. Because this is something you need to be able to do. And then the others, I will do out the expression myself. But work this one out for me. Let me see where you get. So I'm watching and some people not remembering the rules. Look, when you send me an answer, look at it and see if there's something that can be added together. That's what I'm talking about, vigilant. Only one person I've seen sent me the correct answer. So look at it. You're not wrong, but that's not the finished answer. So I'm going to work it out and show you what I mean. So I'm going to do it the easier way. So I'm going to say x, open bracket, x plus 2 plus 3, x plus 2. So I get x squared plus 2x plus 3x plus 6. You can't forget that these two, when you look at it, we got like terms. Where's the like terms? Plus 2x plus 3x is like terms. Okay, so you're going to end up with x squared plus 5x plus 6. And if anybody realize it, right? Anybody realize that in the middle, it is the sum of the two back letters. Anybody remember factorizing the AC rule? The middle is the sum and the back is the product. So 3 times 2 is 6, but 3 plus 2 is 5. How you getting 6x in the middle here? 2x plus 3x is 5x. Check it, you see. So these are the things we can't get wrong. So it means then, if I give you this, then what's going to happen? X minus 3 square. Let's go. This means, what does this mean? First and first, you got to expand it because this means something. This means this bracket multiplied by itself twice. So this actually means x times 3, x minus 3, sorry, times x minus 3. So expand this and tell me what you get, please. This is another skill we need to have. So only one person. 2. We still making some mistakes, guys. We still making these mistakes. A little disappointed, but let's go. Let me show you. Yeah, you're correct. So let's go. X minus 3 minus 3, x minus 3. So let me pause here. Everybody at least have this part right. This is assuming that you're using the easier expansion way to avoid your mistakes. Again, I'm doing this to show you that if you know you ain't getting it right, please to follow what I'm doing. So let me go. X times x is x squared. X times negative 3 is minus 3x. Minus 3 times x is minus 3x. Minus 3 times minus 3 is plus 9. Now, this is where people get into problems. This is where I'm seeing the weird stuff. It's almost like you're saying minus 3 minus 3. Negative 3 minus 3. What's the answer? When the signs are alike, what do you do with the numbers? You add the numbers and put back the sign. So, you see what I'm telling you about these integer rules are coming back? We cannot be making these mistakes. So, it's going to be x squared minus 6x plus 9. So, a few persons got it right. But you see why I was emphasizing our integer laws? Hello, come. These are things we can't be taken for granted. You seen it? Do not forget the integer laws. Doesn't care, it doesn't matter that it's x here. Minus 3 minus 3, when the signs are alike, you add the numbers, you put back the signs. You remember the integer laws. So just for the purpose of making sure we're still on the same page, let's try one more. My dog up and down in the neighborhood terrorizing people, guys, and I don't know if I should go outside for my dog. Anyways, there we go, see? It's better the dog outside than inside here, right? It's traumatizing me. So there we go. Everybody work on this one here for me. And not just work it out, but I need my answer ASAP. You shouldn't take at least a minute and a half to work this out. So vámonos. Okay. I got one person. What happened to everybody else? Let's go. Yep, it is right. She was love at first sight. All right, so let me work it out quickly. It's going to be x minus 2 plus 3, x minus 2. So there we go. We know this is x squared minus 2x plus 3x minus 6. Yep. And then we know the rules here. When the signs are different, because there's an x and an x, what do you do with the numbers in the middle? You subtract the two numbers and you answer take the sign of the bigger number. So you put back your x squared, you're going to get 1. But we don't write 1. So it's going to be x. And is it plus or minus? It's going to be plus because the 3 is bigger. So it's going to be plus x. If I could find my pen. Plus x minus 6. If you know, let me take this opportunity to say, if you know you're not good with this, you know what you got to do. You got to organize yourself. Practice until you get it right, until you can't get it wrong. Or it does only take down the video if it's like American music. If it's like a reggae mix, I don't figure out the trick. If it's a reggae mix, YouTube don't take it down because most DJs don't copyright their mixes. So you know, Miss V got to plug, Miss V got to plug. All right, algebraic fractions. So we get in there. So let's just take a quick minute to take a deep breath and check in with everything we've done so far. How you are feeling about everything we've done so far. And you realize it's not that you didn't know what to do. What we've been doing is paying attention to mistakes that you generally make and trying to make sure that we do what? We avoid them. Correct? Right or wrong? Right or wrong? Because that's the difference here. We're moving ahead. Nobody should be learning none of this for the first time. All of this we should have known from before, but we are trying to solidify our skills. So I hope everything that you, and throughout the session, every time you realize there's something that you're not strong in, you should have a list in your book. Because let me just tell you, in case y'all ain't doing that. In class, if you're just watching on and you realize, okay, this thing I'm not good in, you should write it down. If algebraic fractions is what we're doing now and you're not strong, you put it down so you know in your own time, these are your weaknesses. Everybody understand me? Math is a do subject, You cannot sit down and watch and pass. You can watch a million videos. That don't mean you can pass. Because how you have to do it yourself. You have to train your brain to see questions and know what to do. All right, so let's go. When it comes to algebraic fractions, you treat it just like the regular fraction rules. The only difference is you have to take into consideration that you also are dealing with variables. So in addition to the fraction rules, you have to pay attention to what also? You got to pay attention to the algebra rules. What are the algebra rules? You could only do add and subtract like terms. When you multiply and divide terms, what do you use? The laws of indices. If you're with me, say with me. And while you're here listening, let's go to the fraction rules, which we did last class. To add to fraction, it must have what? The same denominator. So if you need to find the same denominator, you must find what? The LCM. You're not just dealing with the LCM of numbers, you're dealing with the LCM of two letters as well. Similarly, when you multiply, what is the rules for multiplying? Canceling. What allows us to cancel? Something in common. And who got to have something in common? Any numerator and any denominator. And how can we cancel? We can cancel up and down, and we can cancel diagonally. I hope everybody understands what I'm talking about and not completely lost. And then when it comes to division, what's the rules for division? Switch and flip. So I am going to avoid going back over fractions because we did it last week. So I am teaching this with the impression that we all have fractions on lock. So let's jump straight into the algebraic fractions. So suppose I have x over 4 plus y over 3. If you get something like this, you get through. You know what you get through? Look at the denominator. The LCM for this ain't easy to find. That's an easy one. That's just 12. And we know, how do we change 4 to 3? We multiply by 3. Well, we do to the bottom, you do to the top. And we know x times 3 is 3x. So you see, the only difference is that instead of multiplying two numbers, you're multiplying a variable by a constant. Similarly, how do I change 3 to 12? I multiply by 4. Whatever I do to the bottom, I do to the top. Y times 4 is the same thing as 4 times y, which is 4y. It would never be this easy, of course not. So that's why I started off with something simple so we can understand the basics. And let me just get it straight. I'm going to give you guys some terms and I want you to tell me the LCM. Suppose one denominator is x and one denominator is 2. What is the LCM? Because let's be real. Everybody watching, everybody with me, what is the easiest part? The multiplying part is the easiest part. Agree or disagree? It's the LCM part that has give people problems. So let's go. What is the LCM of x and 2? Austin said 2x. Do you agree? It's just like saying 2 and 3. 2 and 3 don't have no factors that are alike. So you have to multiply them. That will give me 6. The same concept applies to variables and numbers. There's no common letter or common number. So I got to multiply 2 times x to get 2x. Hello? What is the LCM of x and y? Excellent. What is the LCM of x squared and x? Let me see who's thinking. X squared. It's almost like saying this, because remember we got to think, you know, if I give you 4 and 2, is the LCM 8? Talk to me. Tell me if you see what I'm showing you. If I give you 4 and 2, is the LCM 8 or the LCM is 4? Isn't x inside of x squared? You see the difference now? You see the point I'm trying to make? Hello? This is the skills that's important. Let's try another one. Suppose I give you 5x and 2y. What's the LCM? Jerome, you're on fire. I see you. No, this one is a little bit more challenging because you have 2 coefficients you got to find to match. And you got to match the variables. The only coefficient that could match is 10. The only variable that could match is xy. If you're with me, say with me. So what I'm going to do is quickly go through some examples just to make sure we're on the same page, okay? After this, everything else is a bit not so hard to go through, but once you guys are okay, we're going to try to get through every single thing on the algebra because I don't want nobody to panic or be weak in any area. So let's start off with this one. If I had 3 over x plus 4 over y, what do we identify the LCM as? Xy. So I put xy here. How do I change x to xy? I got to multiply by y, right or wrong? Whatever you do to the bottom, you do to the top. How do I change y to xy? I got to add the x, you multiply by the x. And let's be real, y'all know how to handle it from here, innit? Because you see, I just really want to make sure you understand this part because that's the part that is give trouble. Everybody got it? So you know this would just become 3y plus 4x. Let's get a harder one. Let's have 2 plus x over x squared plus 3 over x. Again, we already identified the LCM to be what? In x squared. So does this change? This does not change. So you just write back what? 2 plus x plus, how do we change x to x squared? We gotta multiply by x, top to the bottom, plus 3x. Is this the final answer? Can't I add x plus 3x? So what is your really final answer? 2 plus 4x over x squared. And guess what? I could write this and by factorizing. What does factorizing mean? Pulling out what's common in it. So 2, 1 plus 2x over x squared. This is not necessary, but you know why I did this? Because sometimes it is say prove that the answer to this is this. So I just want to make sure you know how to get from here to here. All I did was factorize out the 2. And we should know what I mean by factorize out, right? Pull out what's common between 2 and 4x, that's 2. Okay? Let's try another hard one. Let's try one that has the 5x and the 2y. So let's say 1 plus y over 5x plus 3 plus p over 2y. This is how these questions could come. And you know what? Let me put a subtraction sign here because this is the hard part here. Okay, y'all ready? Come on, guys. Come on, guys. All right. So 10x and 2y, the LCM is 10xy. And we know why, because we were doing the LCM thingy, right? So we know how to find the common LCM. So this is the part where students may make some mistakes. Remember, we need to ask, how do I change 5x to 10xy? First, you gotta multiply 5 by 2, and you gotta multiply x by y. So it's times 2y. Now, this is the part. Because there are 2 things you're multiplying by, you realize why we need the brackets. So I'm pausing right here. So since the brackets already means multiply, I don't need to write times again. So I would just write here 2y, open bracket, 1 plus y. So let's stop right here. Everybody, talk to me. You see how you see the difference between why I need a bracket and why I didn't use a bracket before? Because there are 2 terms in the numerator, you need the brackets, okay? Because you have to multiply the 2y by those 2 terms. Okay, this subtraction sign is important. It's a big subtraction sign in the middle there. So similarly, what do I multiply to 2y to get 10xy? That's a question for you guys. Excellent. Thank you, Myrtle. Thank you, Janelo. So that's 5x to the top and the bottom. Similarly, same thing. Got through all these things here in brackets. So you end up with minus 5x, 3 plus p. Now, this is the trick. When you're multiplying, what are you really multiplying by? Positive 5 or negative 5x? Excellent. That is the part students just get wrong. This sign is going to impact this here. So it's really negative 5x times 3, negative 5x times p. Everybody with me? So let me work it out so we see. So we're going to get 2y plus 2y squared. when I expand this. Then you're gonna get minus 5x times 3. I'm just breaking it down here. Plus minus 5x times p. Agree or disagree? You see where the plus come from? And you realize the minus always comes in front of the 5. So our final answer, 2y plus 2y squared minus what? What is going to become? 15x plus, you put back this plus, you ain't use it yet, you put it back, minus 5px. And you know why I put px, right? Because alphabetical order. What do we do next? We fix the clashing signs. So 2y plus 2y squared minus 15x. This become a minus. Minus 5px. And this is your final answer because none of these things can be added or subtracted from each other. Hello? Something happened and nobody ain't realize what happened. That's the answer. Is that the answer? Yeah, we can't forget. And you know why I did that? All right, let's do this a lot. Yeah, let's do this a lot. Forget things like that was a part of the question. All of this have to be over 10xy. You gotta put it back. It's a fraction. Everybody see that? I'm sure some people ain't even notice. Okay, so that's it for algebraic fractions. What is the key point here? Making sure you choose the correct LCM. And once you choose the correct LCM, you follow the rules. You multiply. Whether you multiply to the bottom, you multiply to the top. You work out your questions. How y'all feeling about this now? A little better? Did this help a little bit? Okay, what time it is? I think I need a small break, guys. So let's take a small break. Is that okay? I need to get some water and hydrate. We only got 2 more topics left. Solving and factorization. So, all right. So can we get a 10 minutes break? What I'll do is send a text when I'm ready to start again. That's all right? So get some water, get some snacks. I know some person said they have to leave to come back or to go home. If you reach back in time, just join back on when you're ready. But yeah, I'll be back. Hi guys. Hi guys. Okay, so I just did an evaluation of the other topics that I would like to go through. And they are a little extensive because they include, even though it's two broad topics. Before I hear talking to myself, let me know if you're here, please. Okay. Okay. I see Janella is here. Anybody else here? Okay. So like I was saying, we have two more topics to go through. Well, 2.5. The half would be changing the subject of the formula. And you should know what that means. Like, so if I have y equals something plus x, you put x in front instead of the y transpose. Then we have solving, but solving have different levels because you have solving linear equations. For example, x plus 3 is 5. And you have more advanced equations, and then you have simultaneous equations. And then there are simultaneous, linear simultaneous, and quadratic simultaneous. And then we have the 5 types of factorization. So what I was thinking is that tomorrow we have a short class. The only issue is that the class may have to be about 6:30. So let me know what y'all prefer, because I don't want to jam too much tonight, because I think we did a lot today. So I'm thinking we end here and we have the 6:30 session tomorrow until like 7:30, 8. That sounds okay? So we could finish up algebra tomorrow. Okay, so what I would like you guys to do though is ensure that you start looking at the past paper videos, the sessions where we did the past paper videos. Please start to go back over them while you're laying on your bed just before you go to sleep. Just open one on your phone and watch it. That's literally all you got to do until you fall asleep. See what you could pull in. Okay, so that's it for today. I think we had an excellent class. So before you leave, just give me a scale from 1 to 10, how you felt about today's session and everything that you would have picked up. Yes, you need to work with your paper. They're supposed to email me where our private candidates supposed to take their exams. So I'm going to try to do that tomorrow. I'm looking at your scores. Everybody seemed that they're looking good. Okay. All right. So that's it, guys. Have a great evening. Have a great week. Put in that work. Good night.